So diving inside of our Greeble, I'm going to put down a null, pressing tab, typing null. I'm just going to label this one incoming geo. Now let's start talking about some of the logic here. So the first thing that we want to do is to give us some kinds of irregular subdivisions of our geometry. So what we'll do is we'll look at the incoming primitives here, separate it out primitive by primitive, and then we will randomly decide whether we're going to do nothing, or we're going to divide in half this way, or divide in half this way, or do a cross subdivision. So we're going to get 4 different primitives out of here. So the way we can do this is with a for each loop. So I'm going to press tab, start typing for, and we want to grab a for each loop. We're just going to put this right down here. We will wire this right in. And I'm going to unclick this piece attribute. So what this essentially does now is turns it into a per primitive for each. So it's not looking for a specific attribute that it needs to break this geometry apart. It will do it actually per primitive. And we should be able to see that our points should be unwelded now. So I have 100 points here, and then coming out 324. So that's confirming for me that it is unwelding our points. So let's take a look here. And now what I'm going to do, we'll take it piece by piece. We're going to look at just a single pass. So we're looking at pass 0. And if you want to change which primitive you're looking at, you can just dial that up or down. But 0 is a good one to start with. I'm going to home in on this by pressing the spacebar, Shift, and H. And now let's subdivide this. So we are going to use, and I have to remember which one it actually is here, a poly split. I'm just going to put it down here manually. And let's make sure that we are looking at wireframes. So for the split location, if you look at the help file, I'm not going to bring this up, but there is a specific kind of formatting that you can use to decide where it's splitting the primitives. Essentially, it's basically kind of like a knife tool, but you can decide exactly where it's going to split based on percentages or which edges or between which points you'd like to make it cut. So there is a format for that, and the format for splitting right in the center of the edges is to tell it which primitive number you're interested in. So currently, because we're only dealing with one primitive at a time here, each primitive is going to be labeled primitive 0. It doesn't really matter which single pass we're looking at, because it's only aware inside that there's one primitive here. So it starts with primitive number that you're interested in, so that's going to be 0. And then lowercase e, telling it that we want to split by a certain edge. And then I'm going to type 1 here, and then change this to edge loop. And you can see what that's done is that's created an edge loop right here, right directly in the center, so perfectly even split. So we've succeeded in doing that split. Let's move that aside. I'm going to copy and paste. And here I'm also going to put down a switch. Let's put down a null also. So we'll start with something like this, and we can just label this no split, or usually capital if we're doing nulls. So that's no split. And then we have split one way. We'll just wire that in, wiring that in, and then just change this to 2. Now when we look, we should have 0, 1, 2, and then we're going to need one that does a secondary split as well. So I'm just going to copy this, paste it directly under, and then wire that in as well. And then I think we may want to change that. There we go. So you can see we're taking this result and then doing a further refinement and then doing a split from there. Now let's take a look at everything here. Turn off single pass. And we can see that we're splitting everything uniformly. We're not randomly selecting which input we want. So let's figure out how to do that. If we select this top piece here, the for each begin, we can do this thing called create meta import node. And let's just click on that. That's going to create a node that allows us to fetch exactly which iteration we are in here. And we can use that as a detail attribute. So if I middle click here, you're going to see that we have now detail attributes associated with this node, and one of them is iteration. So that tells us exactly which iteration we're in, as well as we can figure out what the maximum number is as well if we want to do some kind of special loop stuff. But here we just want to create a random seed based on which iteration we're in. So I'm going to call this prim iteration, or we can call it split iteration. Doesn't really matter. Split iteration is fine. Now we're going to use a format here for our switch to fetch this detail attribute and make it random. So first, let's call the detail attribute. And I'm just going to write detail, parenthesis, and then you see that we need a path to where we're getting that attribute from, the name of the attribute, and then we need to know whether it's which component it is, if it's a vector attribute, or if it's not, we simply just default to 0. So using relative paths, we're going to quote / split iteration. And then the name of our attribute in quotes is iteration. And then 0 for the index of the component. Now what we want to do is randomize this between 0 and, let's see, so 0, 1, 2, 3. So between 0 and 3. And we need to make sure that we're returning an integer here. So random, feed this in as our seed, times 4. So that will make sure that we never actually hit 4 here. So we'll be between 0 and 4, and then we'll take the floor of that value. So I'm flooring that, and then going all the way up here, hitting enter. And there we go. We see that we have some that are split vertical, some that are split horizontal, some that aren't doing anything, and then some that are doing both. While we're here, let's just add a seed in here as well. We're going to do this as a spare parameter that we can just call into here, and then we'll use something to control the spare parameter down here. So I'm just going to do this. If I click this gear icon, I can choose to edit the parameter interface. And this allows us to add additional parameters into our node, but it doesn't save it like an asset. It's just on a per node basis. So we will grab an integer, just put it right here in the root. We'll call this seed and just click accept. And we see that seed is down here. So let's make sure that our detail here, this is fetching our detail attribute, and right in between these two parentheses, let's add our channel, and then a parenthesis, just a quote, seed, and then end the quote. That might be a little tough to see, but let's go over here and check. Just like that. So when we're referencing something that's on our node like this, we don't need the .. We simply just call out the channel as a string. And just to check that that's working, there it is. You see as we dial up and down that our random seed value changes. So that's a good first step. Let's go ahead and save this. Save the file, and then move on to the next step. So let's assume that we're going to potentially have triangulated pieces of geometry coming in as well, and we'd like to be able to handle that, as well as potentially n-gon situations, which if you're not familiar with an n-gon, that is a polygon that has more than 4 edges to it, or more than 4 points to it. So we need to accommodate for those scenarios. So I'm going to take our grid here, and instead of quads, let's turn this into triangles. Maybe alternating triangles, just look at something kind of unique. So the way our thing is set up right now is our greeble doesn't really do much there. So let's take a look at how we can address this. I'm just going to put a null here just to give us a placeholder, just so that we know what we're looking at here. And we'll call this single prim. Okay, and working off this next chain here, let's do this. Let's put down a try divide. So try divide, and then just throw that right in there. And of course, we're only looking at 1 here, so let's put that up to 1. So that does a singular triangulated division. And then I also want to make sure that if we have n-gons coming in, we can work with that as well. So let's do this. There's another SOP here called a divide. So I just press tab and type divide. And what this does here, it will automatically take n-gons and convert that into triangles by using this stuff here. And as long as we have nothing else going in, that's fine. So let's wire our single prim into a divide. We'll put down a switch. So let's say that it's a triangle first coming in, which means we don't need to do anything to it. And then secondly, we will figure out if this has more than 4 points to the primitive, then we'll run through this divide here. So all we need to do for our switch is an expression, and we'll simply count the number of points coming in on this primitive. To do that, there's an expression called endpoints, and all it wants to know is which SOP are we interested in. So quote // single prim, and we'll put this in an if-then statement. So first of all, let's just do the condition here, which is if it's greater than 3, then we'll do this thing. So we'll say if, and then we have our condition here. Then it wants the true statement. So if this statement is true, then we want input number 1. And if it's false, we want input 0. And if I just click here, that's telling us correctly that that is giving us input 0 because it's not an n-gon. Okay, so we will have that going into here. Let's see, what's our little thing here? Oh, don't worry about that yet. Okay. So we've set up one division. Now let's set up a second division here. So I'm just going to simply copy and paste and wire that right into there. Now let's see, maybe here, let me see something. We can set to 2 for now. Maybe we'll change the way that this works a little later because I don't really like getting these long shapes here. But we'll just set this up and then we'll continue to refine it. So again, we'll set a switch here. And let's assume we don't want to do anything first. Then we want 1 division, and then we want 2 divisions. Go all the way down here. So we can see that these are quads. So I'm going to put a null here and we'll just label that. Quad. We'll put a null down here. And we will label this try. Now for this switch, I'm just going to copy the exact expression here. Paste that in. 0, 1, 2, except we only have 3 choices here. So let's make sure that we change that 4 into a 3. And then again, we'll have to put a switch down and decide whether we're switching between quads or tries. So again, here we're going to have to use an if-then statement to determine how many points are coming in on our primitive. So I'm just going to copy that here. Now we'll paste this. So if it is greater than, let's say, if it's equal to 4, then we're going to want input 0. If it's not a quad, then we'll go 1. Let's turn our loop on here. And that's showing something. So it is telling us that there's, here's the problem here. So we're missing a G. So let's correct that. Same here as well. That's right up here. There we go. Now that should go away. And let's see what the issue is here. So this is missing the seed value as well. So let's make sure that we're getting the same seed value. Please excuse the barking dog in the background here. Let's put seed in here as well. So we just need to grab an integer, drag this here, seed, seed, click accept. And that gets rid of that error. Let's make sure that that's working. Then let's go back here to quads. And it looks like we've got that sorted. So we'll take a look at the triangles and see if we have some other solution that might make that look a little bit better. For now, let's save our node type, save the file, and keep going. Okay, one last tweak to the triangles here. We'll just go back to alternating triangles, go back into our Greeble, and now let's do this. Let's select our try divide here, and we're going to turn that to 0, and we'll use number of splits instead. I think that's going to give us a better result. So let's take a look at just one pass here. Whoops, single pass. Yeah, so we can see how that split that up here. Now let's take a look at this one right here. Turn that back to 0, number of splits. And let's see if this is any better to use 2. Nope, so let's go with 1 here. Let's see what happens if we wire that straight in. So we'll go with 1. And then let's put down another one next to that, or underneath that rather. There we go. That's a better pattern. Go back to our out, turn off single pass, and that looks quite a bit better. So you can keep playing around with whichever division schemes you like and whatever seems to work and be aesthetically pleasing to you. For now, this is where we're going to stop on our division scheme and move on to the next part of this setup here. So we will save the node type and save our file and continue on.